Okay, so on tomorrow's test, I'm going to work through some problems with y'all that's going to look very, very similar. Okay, for problem number one, if you look at the worksheet that I have posted in Classroom, it says complete a table from a graph given. So for number one, you're going to have a graph given to you, and then you're going to have a table given to you with the X values, and you have to drag and drop the Y values. Okay, so I'm not giving you an example of that only because it's so easy. I look back at activity 15 quiz and almost everybody got that problem right, which is why I put it on your test tomorrow. Okay, so because this covers unit 3, I put one question from activity 15 and 2 questions from activity 16, and then the rest are from activity 17. So this problem comes from activity 16. Okay, this problem is on page 248 in your book. And it's number 10 on 248. When you print out the slides, it's going to be a little small, but here is the problem, okay? If you need to look it up in your book, you can. So which graph represents the solutions of the inequality 2x minus y is greater than or equal to 6? And you're given 4 graphs. Well, I'm going to go to Desmos and I'm going to type this inequality in Desmos, and then I'm going to match the graph in Desmos with one of these graphs given to me. So I'm going to go to Desmos and I'm going to type in 2x minus y is greater than 6. Okay, so I'm going to go to Desmos, 2x minus y, and then I'm going to use my keypad down here, is greater than or equal to 6. Okay, so if I zoom out, this is what my graph is going to look like. I'm going to have a line going in the upward direction, and my shade is to the bottom right. A line going in the upward direction with the shading to the bottom right. So let's look at my options. My line was going in the upward direction. So I can automatically eliminate A and B because my lines are going in the downward direction. Okay? So C and D are the only lines that are going in the upward direction, as my graph in Desmos does. It goes in the upward direction. Now, my shading was to the bottom right. Looking back at my graphs, where's my shading in the bottom right? Right here for C. So the answer for this problem would be C, where your line is going in the upward direction with the shading to the bottom right. So on tomorrow's test, you're going to type in your inequality that you're given, and you're going to match your graph with one of the graphs given just as you did in this problem. Now, the only difference is that tomorrow's graph, 2 of your graphs are going to have dotted dash lines. So when you type in Desmos, you're going to have to pay attention. Is it a dotted dash line or is it a solid line? And you can automatically eliminate 2 of the graphs just by the line itself, and then look at the shading. Okay, for number 3, this graph is on page 240. Which order pairs are in the solution set of the inequality represented on the graph? So I'm going to graph these order pairs, and I'm going to see where these order pairs fall as a solution set for this inequality that's graphed. And if you recall the inequalities, points that lie in the shaded region or on the solid line are solutions. So let's see which of these points fall in the shaded region or on the solid line. 250. 250 would lie right here on the line. Each of those squares are 10 units, so 80, 190, 200, and then 10, 20, 30, 40, 50. So this point lies on that line. So 250, you would select it as being a solution. 150, 150 will be at 150, 150. It lies here, outside of the shaded region. So it is not a solution. Not a solution. So you would not select it. 225, 25, 10, 20, 5, 25, 10, 25 is right here in the middle of that unit square. It lies on the line, so it would be a solution because it lies on the line. 20, 120, 20, 120 lies over here in the shaded region. So 20, 120 would be a solution. 120, 200 120, 200 lies here, outside of the shaded region. So it would not be a solution. So you would not select that as a solution. So the only 3 points that are solutions to this inequality are the 2 that lie on the line and the 1 that lies in that shaded region. Okay, number 4. This is a definition. Systems of linear equations in 2 variables with exactly one solution. One solution. So you have to know, what is the definition of one solution? One solution graphs look like this. It's a line that intersects another line at one point. So what does the graph of 2 intersecting lines have? They have one solution. So one solution lines must have intersecting lines. Intersecting lines. It's 2 lines that intersect at one point, so they have one solution. Meising graphs a system of linear equations on his calculator. When he looks at the result, he sees only one line. Assuming that he graphed the equations correctly, what could this mean? So Meising graphed 2 equations. Equation number 1, and then he got a second equation, and equation number 2. And I'm going to try to draw this where you can see both colors, but it ends up being, the best I can do there, it ends up being one line, but 2 equations. So where do these 2 lines intersect or touch or cross? They intersect and touch at all points. Okay, so when you have 2 graphs that lie on top of each other and it only shows one line, that's infinitely many solutions. They touch and cross at all points and all solutions. They intersect and touch at all points. Now, the last definition that we talked about was no solution. Each coordinate grid shows the graph of a system of 2 equations. Which graph represents a system of equations with no solution? No solution. So we have 2 intersecting lines that intersect at one point. So this would be one solution. We have 2 lines that overlap each other. So this is going to be infinite solutions. We have 2 lines that never touch. They're parallel and they never touch. Because they never touch, that means that they have no solution. We have 2 lines that intersect at one point, so that's one solution. We have 2 lines that overlap and are on top of each other that form one line, so that's going to be infinite solution. They touch at all points. And the last one, I have 2 lines that never touch. They never touch. So that would be no solution. They never touch. Okay, so moving on. Number 7. What is the solution of the system of linear equations shown? So you're given a graph, not the system itself of the equations. You're just given the graph and you're asked, what is the solution? Where do these 2 lines cross and intersect? They cross and intersect at this one point, which is 5, where x is 5, and 4, where y is 4. So that would be A, where x is 5, y is 4. They intersect at this one point, 5, 4. Okay, number 8. Which ordered pair is a solution to the system shown to the right? Now you're given the system as an equation, So you're going to have to go to Desmos, graph these 2 equations, and determine what the solution set is for the point in which they intersect. So let's go to Desmos. And I'm going to type in 2/3 x plus 3 and negative 3x plus 14. So I see my 2 lines here. They intersect at one point, which means I have one solution. If you click and hover over that point, it'll give you the ordered pair there. You'll see 3, 5. 3, 5. So going back to my answer sheet, I would select the answer 3, 5. Okay. Number 9, the system of linear equations and its graph is shown. So I have a system here and its graph. This is the graph that goes with this system given. Which system of linear equations represents another pair of parallel lines? So we're looking to see which of these system sets would show me another parallel lines that looks like this graph. 2 lines that never intersect. So you would go to Desmos and you would type in and graph all of these systems. If you go to Desmos and type in all of those systems, you'll see that D ends up being parallel lines. And I'll show you. I'm not gonna graph all those for time purposes, but I'm gonna graph part D for you just so that you can see. Okay, so 4x minus 2y equals 2. And then y minus 2 equals 10. Oh, I did something wrong here. Y minus 2x, I messed my x, equals 10. Okay, so if I look at these 2 lines here, I will see that they are parallel lines. And if I zoom out, I will see that they will remain parallel lines infinitely, which means that this system is the other pair of parallel lines. So you would select D. Okay, so on your test tomorrow, you're going to have to graph all of these to determine which system provided is another pair of parallel lines. Okay, number 10. Which system's solution is represented by the graphs shown below? Okay, so again, you're going to have to graph all of these systems using Desmos. And if you want to practice this, you can individually. But when you graph all of these, 2 of them, which I believe is A and D, end up over here in the 3rd quadrant. Okay, so you can automatically rule out A and D because they show up in a totally different quadrant. If you graph C, you will get the intersection point, I believe, is at 2, 4. You'll get an intersection point at 2, 4, where the graphs look similar to this. Well, it's a little off, but that's what your graphs look like for C. Now, if you graph B, and I'll show you, if you graph B, it'll look exactly like what is there. So I'm going to go to Desmos, and I'm going to show you what B looks like. Okay, so for part B, 2x minus 6 and 1/5 x plus 3. So there's my graph, and if I zoom in, I'll see that my intersection point is at 5, 4, and I have a line that is positive and a line that is positive, and they intersect at 5, 4. So looking at my problem, I have a positive line, intersecting at 5, 4. Okay, so as long as you can match the graph in Desmos to the graph on your paper, you should be able to get number 10 correct. All right, number 11. What is the sum of the values of x and y that solves the system of equations? So I'm going to take the system of equations and I'm going to graph it in Desmos. X plus y equals 7. X plus y equals 7. And I'm going to graph the second equation, which is x minus 3y equals negative 1. And I get that the solution is 5, 2. I get that the solution of this system is 5, 2. So I'm going to go to my paper. The solution of this problem is 5, 2, where x is 5 and y is 2. What is the sum of the values of x and y? Well, sum means add. What do you get when you add the values of x and y? What is 5 plus 2? 5 plus 2 is 7. 7 is the sum of the values of x and y that solves this system. So you have to solve this system, pull out the ordered pair, and add x and y to get your answer. Okay, number 12. How many solutions does this system have? Let's graph the system and see what it looks like. When you graph the system provided, 4x plus 2y equals 10, y equals negative 2x plus 5. When I graph those two systems, I see one line. I don't see two lines. I see one line. And if I turn my purple line off, I'll see green. If I turn it on, I'll see purple. So that tells me that the two lines overlap. What does it mean when two lines overlap and forms one line? They touch in all places, which means it's infinitely many solutions. No solution is parallel lines. One solution is intersecting lines. And two solutions, we've never talked about anything that even has two solutions. That'll be algebra 2. So nobody should be selected two solutions. Okay, number 13. Which system of equations has infinitely many solutions? Well, you got to know what infinitely many solutions looks like. Again, infinitely many solutions is two equations that form one line that touch in all places. Okay, so if I graph the first set of equations there, x plus y equals 3, and 2x plus 2y equals 6, they touch in all places. They touch in all places. So the system that touches in all places that represents infinitely many solutions is A. Now, for practice purposes, you can go and graph these two systems on your own once we finish with the Google Meet. And you'll see that those do not have infinitely many solutions. One is no solution and one is one solution. Okay, 14. 14 is one of the hardest ones. Okay, 14. Roberto has 8 coins that are all nickels and dimes. So we have dimes and we have nickels. We have dimes and we have nickels. And together he has 8 coins total. But we don't know how many coins he has of dimes and how many coins he has of nickels. We just know that between the two, he has 8. X represents dimes and Y represents nickels. So X dimes and Y nickels together gives me 8 coins. So I can use that information alone to write one of my systems. My nickels plus my dimes added together is 8. The number of nickels I have plus the number of dimes, number of dimes I have plus the number of nickels I have is 8. Well, I can automatically eliminate A and C based off that information. B and D both have X plus Y equals 8. Okay, so let's go to my next information. They are worth 50 cents. So my dimes and my nickels together, the value of them is 50 cents. The value of them is 50 cents. Well, what is the value of a dime? The value of a dime is 0.10. What's the value of a nickel? The value of a nickel is 0.05. And we know that X represents dimes and Y represents nickels. So 0.10X plus 0.05Y equals 50 cents. So I can eliminate B because that gave me 10 and 5 for the value of a dime and a nickel. A dime is not worth $10 and a nickel is not $5. A dime is 10 cents and 5 cents. So your answer would be D. Okay, and last one. Pedro placed an order with an online nursery for 6 apple and 5 azalea. And the order came to 147. So we have apples and we have azalea. Okay, he placed an order for 6 apple and 5 azalea, and his total came to 147. Okay, and then he placed an order for 3 apple and 4 azalea, and his total came to 96. So we're going to use X for apple, and we're going to use Y for azalea. Okay, so 6 apple, 5 azalea, 3 apple, 4 azalea. So if I add the two together, that would give me the total. So the system that I have here is 6x plus 5y is 147, and 3x plus 4y is 96. So I'm going to go to Desmos, and I'm going to type in that system to see what the solution set would be. 6x plus 5y equals 147. 3x plus 4y equals 96. Okay, the point in which both of those lines intersect, if you click and hover, is at 1215. So the solution is at 1215. So the solution of this system is at 1215. Well, what does that mean? That means that apple trees are $12. Apple trees are $12. And azalea trees are $15. The question is, what was the unit cost for each apple tree? Apples were $12. So you would select B, $12.